I ordered these digital potentiometers from AliExpress. It didn't go well. But before I show you what happened, let me explain why I needed them in the first place. I'll be using one of them in the next revision of my ESP32 Power over Ethernet smart home sensor for my microphone sound sensor based on this design, to replace the potentiometer that is used to select the sound threshold. If you are interested in smart home hardware, please check out my project. Let's start with the basics. Potentiometers are ancient analog resistors with a knob to change its value. Digital potentiometers are like having a tiny robot turning the knob for you, except there is no actual knob or robot, but you get the idea. But first, we need to understand how potentiometers work. A potentiometer is a resistor with 3 terminals, 2 fixed ends and 1 movable, called the Viper. The total resistance between the ends never changes, but as you move the Viper, you're splitting your resistance into 2 parts. Slide it one way and you increase the resistance on one side while decreasing it on the other. A potentiometer can be used in clever ways. For example, a voltage divider. Just connect one end to ground and the other end to the supply voltage. The Viper can now output any voltage between these two. For example, you want 3 volts, just position the Viper accordingly. It's a perfect match for Arduino's analog input. It's like they were made for each other. Though keep in mind that this voltage output is pretty weak. You will need an amplifier for any serious work. As soon as you draw current, the voltage will drop. Potentiometers are also used as variable resistors by connecting one end to the Viper. Just keep the power limitation in mind. You don't want to release the magic smoke. So how can we control our potentiometers digitally? There are 2 ways to control resistance digitally. The first way is to just connect it to a motor. And in fact, this is something that you'll find in audio studios or even on my stereo. But while this works, it's not exactly elegant. Motors are bulky, noisy, and have moving parts that can wear out. This brings us to the second way of controlling potentiometers digitally. Digital potentiometers are what happens when a potentiometer and the microchip have a baby. It works like this. You have a lot of resistors in series. It's called a resistor array in my X9C digital potentiometer. For example, there are 99 resistors. And then you have a lot of transistors, in my case 100, to connect or disconnect the Viper to any Viper tap point. Think of it like having 99 tiny resistors with 100 switches. Each switch can connect the Viper to a different point in the chain. How do you control these digital potentiometers? There are different solutions. Some of them have I2C, some of them have SPI. The X9C in my hand has something simpler. It has 3 control inputs. A chip select for device selection, up-down for direction selection, increment for moving the Viper into the direction indicated by the up-down input. The value is also saved into a non-volatile memory. This means when the power is removed, the digital potentiometer still remembers its last state, just like the ancient relatives with the big knobs. Compared to traditional potentiometers, digital potentiometers have a limited voltage range, a very low power rating, and usually a higher temperature coefficient, so they drift more with temperature. However, digital potentiometers usually have a longer mean time to first failure, also a reduced impact of environmental changes such as temperature cycling or humidity, and it also allows the user to reliably return to the same Viper position. Try that with an analog potentiometer. If you would like to learn more about the differences, you can find a link in the description. One more difference for analog applications you also need to keep in mind is that parasitic capacitance is inherent to all digital potentiometers. There will be a part 2 of this video where I actually connect one of these digital potentiometers to my Arduino Uno. In fact, I already tried that, only to find out that I bought fake chips from AliExpress where plug and play means plug and pray. If you learned something new, please like this video. Subscribe to this channel if you would like to know if the next AliExpress shipment also contains fake chips. And if you're interested in smart home hardware, please don't forget to check out my ESP32 Power over Ethernet sensor playlist. Thank you for watching. See you in the next video.